Neutron stars, one of the most extreme and violent things in the universe.
If you're a true space enthusiast, I'm sure their mystery has already captivated you. Or maybe you're hearing about them for the first time. Either way, you're in for a treat. Today, we're diving into one of the most unique, beautiful, and mysterious cosmic objects in the universe. Alright, let me take you on a little journey. Imagine a massive star, much bigger than our sun, living its cosmic life, burning brightly, fusing elements, and shining like a beacon in the universe. But like all great things, its time eventually runs out. When it can no longer hold itself together, it explodes in a supernova. Yeah, we all know that. A beautiful yet violent death. And just like ancient Egypt, we are not as fascinated by how it lived, but by what happens afterward. Now, I know what you're thinking. Doesn't a massive star usually turn into a black hole after a supernova? Sometimes, sure, but not always. If the star isn't quite massive enough, it leaves behind something even stranger, a neutron star. So what exactly is a neutron star? Once the supernova gets over and the star failed to pass the bar to become a black hole, its core remains. Yes, the crushed core of the massive star, compressed by gravity into an object so dense and compact it almost defies logic. Imagine squeezing the mass of our sun into a bowl, no wider than a city. That's a neutron star for you. Small in size, but with gravity so intense it can warp spacetime around it. To put its density into perspective, a teaspoon of neutron star material would weigh about 4 billion tons. That's like taking every car, buildings, and bridge on Earth and compressing them into something the size of a sugar cube. Hard to wrap your head around, right? These stars don't just sit still, they spin super fast, sometimes hundreds of times per second. These spinning stars, called pulsars, shine beams of light like cosmic lighthouses. And their magnetic fields? They're unbelievably strong. So strong they could mess up electronics and even atoms from millions of miles away. Definitely not something you'd want to get close to. So, in a nutshell, neutron stars are what's left when a massive star goes out with a bang, leaving behind one of the most extreme and fascinating objects in the universe. Hold on, they didn't qualify for a black hole doesn't mean they are ordinary. You know, there are people who drops out of college and becomes one of the most famous person in the world because they are unique and talented. Neutron stars are just like that. So let's dive into why they are so unique and fascinating. Alright, let's focus our camera on the most extraordinary and unique side of a neutron star. They aren't just leftovers from a star's death, but some of the most extraordinary objects in the universe. These things break every rule in the cosmic playbook. First, let's talk about their density and gravity. Honestly, that alone puts them in a league of their own. Imagine standing on the surface of a neutron star. Well, you wouldn't actually stand. You would be flattened instantly. Their gravity is so strong that if you dropped a pebble from just a few feet above the surface, it would hit with the force of a nuclear bomb. The gravitational pull is about 2 billion times stronger than Earth's. It's like the universe speeds up the intensity dial to red zone of a car. But that's just the beginning. The second unique feature is its speed. Some neutron stars, called pulsars, spin faster than you'd believe. Picture this, the fastest pulsar we know spins around 716 times per second. This is equivalent to 42,960 revolutions per minute. That's like spinning a pizza dough so fast it could cut through steel. And yet, despite this insane speed, these stars remain incredibly stable. Their precise timing makes them nature's most accurate cosmic clocks. If you are wondering about the name of the pulsar who spins 716 times per second, we see the name on the screen. I am not going to pronounce it. I don't get it why scientists can give a catchy name to them like Iron Man or Tommy, like my neighbor's dog who loves to spin to catch his tail. Anyway, back to the topic. Now, the third unique feature, their magnetic fields. If you think Earth's magnetic field is impressive, a neutron star would laugh in its face. These stars have magnetic fields up to 1 trillion times stronger than Earth. that's enough to completely scramble the molecules in your body from a distance. The strongest ones, called magnetars, can generate magnetic storms so intense they could disrupt satellites from halfway across the galaxy. Think for a second about that to feel the magnitude of it. And then there's their light show. Pulsars shoot out beams of radiation as they spin, creating a cosmic lighthouse effect. These beams can be detected from Earth, even from thousands of light years away. They flash with such precision that scientists use them to study everything from gravitational waves to the fabric of space-time itself. But you know what's even cooler? Neutron stars might hold the key to understanding matter in its most extreme form. At their core, the pressure is so immense that atoms collapse, and we're left with a dense soup of neutrons. But scientists suspect there could be something even weirder at play. These are called Quark Matter. I won't go too deep into it in this video, but in short, it's a state where even neutrons break down into their most basic components, which are called quarks and gluons. This could unlock some of the universe's deepest secrets. And guess what? Neutron stars are the only places where we can even begin to study this. Now I think you agree with me that neutron stars are the Steve Jobs of the cosmos, right? They push the boundaries of physics, challenge what we know about matter and gravity, and create some of the most spectacular phenomena in the cosmos. Now the question is, if the neutron stars are so unique and extremely talented, aren't they supposed to play an important role in shaping the universe?
That's exactly what we will discuss in our next video. If you have liked this, don't forget to like and subscribe. And stay tuned, because the next video will be even more intriguing as we dive into how neutron stars are shaping our universe, and most exciting topic of all, the neutron star mergers. Stay tuned.